What up, geometry students? Doing the simplifying radicals and Pythagorean theorem to find diagonal distance homework. Question number one, we want to simplify the square root of 8. The way we simplify square roots, and this is because back in the day we didn't have calculators. We had to do some approximations of these square roots by hand. The easiest way to do that was to simplify the square root first before trying to calculate. And what I'm going to remember are the perfect squares: 4, 9, 16, 25, 36, 49, 64, etc. Because we know these numbers are easily square rootable. The square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5. And what we want to do is rewrite these square roots that are bigger into the square root of a biggest perfect square times the square root of another number that is not square rootable. It's not as nicely square rootable. So I know that 8 is 4 times 2. So I say root 8 is root 4 times root 2. Now the square root of 4 is 2. The square root of 2 is just the square root of 2. Is not nicely square rootable. The simplified version of square root 8 is 2 square root 2. Now square root of 9 is one of those nice numbers. Square root of 9 is just 3. So we don't have to go through this whole rewriting process. We just know that the square root of 9 is 3. The square root of 10 is not a number that can be simplified because 4 does not divide evenly into it. And if you want to, you can use a calculator to help you. You can start taking numbers like 10 and dividing it by all of the perfect squares until one divides nicely into it. None of them do, so that means the square root of 10 is just the square root of 10. This is fully simplified. So we got that done. Now, the square root of 32 is one that a lot of students mess up on because they think it's square root 4 times square root 8. And I say you're correct. However, there's a bigger number that goes into 32. That's a perfect square, and that's 16. 16 times 2 is 32. Root 16 times root 2 is root 32. 4 root 2 is the simplified root 32. The square root of 50. Well, 25 divides nicely into 50. Root 25 root 2 is root 50. 5 root 2 is root 50. 72 is another classic one that students mess up on. They think it's root 9 root 8, and they say 3 root 8. And I say, well, isn't root 8 root 4 root 2? So isn't this 3 times 2 times root 2, which is 6 root 2? And what I'm really trying to show you is that it's easiest if you pick the largest perfect square. 36 goes into 72 twice. So root 36 root 2 is root 72. 6 root 2 is root 72. Try a bunch of them. Get the biggest one for root 90. Root 90 is root 9 times root 10. 3 root 10 is the simplified root 90. Root 80. Be careful. Don't just think it's 4. Divide 80 by some numbers until not by some perfect squares until we find the largest perfect square. And turns out 16 times 5 is 80. So root 16 root 5 is root 80. 4 root 5 is 80. If we got a number in front of it, like for number 9, we have 3 root 18. We'll keep that 3. It sticks around. Root 18 is root 9 root 2. So that means we have this 3. We have this root 9, which is 3. And then we have this root 2, which is root 2. Now, we are multiplying all these things together, which means the 3 gets multiplied by the 3 to give us 9, not 6. That's the same thing for 2 times root 8. It'd be 2 times root 4 times root 2, which is 2 times root 2, which is 4 root 2. It's not because it's 2 plus 2 is 4, it's 2 times 2 is 4. Root 7 cannot be simplified, so we're just going to leave it as 4 times root 7. There's nothing we could do. Root 16 is just 4. So 5 root 16 is 5 times 4. which is 20. All right, and then we get into the exploration of the Pythagorean theorem, which equates areas and lengths. Well, it's like it uses areas to find lengths. We want to find the length of this diagonal here, like from 0, 0 to 2, 1. And we're trying to find this area of this blue square. Well, we know it's going to be C times C, or it's C as a square's area. Okay, C times C. Great. Well, we're going to start with this bigger outer square, which goes from -1, 3 to 2, 3. It's got this length of 3. And then from 2, 3 to 2, 0, it's got a length of 3. So we know that the outer square area is 9. I'm just double checking that it's a square and the lengths of the same. The area, the total area of the 4 right triangles. So adding up all of the areas of the triangles. Each triangle is going to have a base of 2 and a height of 1, or vice versa. This will be a 1 and this is a 2. And remember, the area of a triangle is just the area of the rectangle that surrounds it, dividing by 2. So each of these triangles' areas is 1. So this is 1 as well. This is 1, this is 1. Which means the total area of the 4 right triangles is 4. If I subtract the area of the 4 right triangles from the area of the outer square to get the area of the inner square, I get that the area of the inner square is 5. Well, if 5 is the area of the inner square, then I got C squared equals 5. I get C equals root 5. Just take the square root. Now, what we can see is that, let's just focus on this triangle. Let's not really look at the areas really, but rather use the Pythagorean theorem, which is really using the areas. That's saying the sum of the areas of the legs, sum of the areas of the squares of the legs of the right triangle equals the square of the hypotenuse, or the area of the square of the hypotenuse. 2 squared plus 1 squared is 5. C squared equals 5. C equals root 5. We get the same thing. So this is kind of where the Pythagorean theorem came from. It's like, you want to find lengths, use areas. So when we find lengths of line segments, really, we just have to understand how they can be turned into right triangles, where we have a horizontal length and a vertical length. We have to figure out those lengths. Now, we like to stack our points on top of each other. -1, 2, 1, 3. We can see this is a +2, this is a +1. So this is 2, this is 1. How do we find this diagonal? A squared, B squared equals C squared. A squared plus B squared equals C squared. So we have this 4 plus 1, which is 5. So C is root 5. From 210 to 37. So from 2 to 3 is a x change of 1. From 10 to 7 is a y change of -3. You don't have to worry about using a plus or a minus in the Pythagorean theorem, because -3 squared is the same as +3 squared. So -3 squared plus 1 squared equals C squared. 9 plus 1 is C squared. C equals C squared. C's area as a square is 10. That means C's got to be root 10. -3, 3, 2, 1, 1. If you want to do, just stack your numbers on top of each other. -3, 3 to 1, 1. And we got -3 to 1 is a +4. We got 3 to 1 is a -2. So this -3 to this 1 is this +4. The y change is a -2. So I got the 4 squared, which is 16. I got the -2 squared, which is 4, equals the C squared. So C squared equals 20. C will equal root 20. Root 4, root 5 gives us 2 root 5. Cool. 5 negative, this is question number 17. 5 -2 to 10, 3. 5 to 10 is an x change of 5. -2 to 3 is a y change of 5. So I have 5 squared plus 5 squared equals the C squared. This is 25 plus 25. So this is 50 equals C squared. This is root 25, root 2. when I square root both sides, and I get 5 root 2. How do we find the distance between 2 points? It's the same as the length of the line segments. Don't worry about the word distance. There are things called the distance formula, but like we're not really thinking about it. We are thinking about y change, we're thinking about x change. We're not really using formulas. We kind of are doing a formulaic process, but we're not really using a formula. So I can see from -2 to -4, that's a x change of -2, and 4 to 0, that's a y change of -4. You could consider it the opposite way of a +2 and a +4. This is my horizontal. This is my vertical. -2 is my horizontal change. -4 is my vertical change. So my horizontal change squared is 4. My vertical change squared is 16. And again, we get this root 20 as our answer. 2, 3 to 1, -4. 2 to 1 is a -1. 3 to -4 is a -7. So we have this -1 squared, this x change squared, plus this y change squared equals our c squared. So this is 1 plus 49, which is 50. Oh, look at that. 50 shows up again. So c is root 50. Root 50 is root 25, root 2, which is 5 root 2. What is the distance between the origin and the point D? 3, 4. Well, if we're going from the origin to the point, really, they're already telling us the x change and the y change. We just have to take this x coordinate and this y coordinate, and it's the x change and the y change. So I get the x change of 3 squared, which is 9. The y change of 4 squared, which is 16. That will equal the diagonal distance squared. So 9 plus 16 is 25 equals c squared. C equals 5. That is the distance. Here from 0, 0 to, for question number 21, 0, 0 to -2, 4, the x change will be -2. So that's my x change. My y change is 4. That's my y change. That equals c squared. I have 4 plus 16. I'm sorry for getting the same answer so often. It's just like hard using the Pythagorean theorem to get things that are simplifiable, which was my goal. So sorry that we had 5 root 2 twice and we had 2 root 5 times or whatever we had. But I hope we understand. And we'll see you for the next entrance ticket, and we will start transitioning outside of just length of a diagonal to more interesting things we can do with this Pythagorean theorem. Okay? Peace.